Section A. I should turn the TV on. Did anyone see Aquaman? Is Aquaman any good? Is good? Better? Worse? Compare?
That's out of all DC movies.
For real?
Like for me, I think.
Cool. Then I should watch it, so.
Including Wonder Woman?
Yeah, I think it's better than Wonder Woman.
Really? Wonder Woman was pretty good though.
And Aquaman is better.
It's better. Strong claims. Okay, we'll have to test that. Right, we'll start with you, Andek. If you can just read A1 to me, please.
A bottle of mass 200 grams with a speed of 12 meters per second is incident normally upon a vertical wall. And
Oh, okay, hang on. 300 grams
yeah,
and,
12 meters per second speed.
yeah, a vertical wall and, okay, keep going. Incident onto a vertical wall, yeah.
And rebounds in the opposite direction at the same speed.
Ah, I see. So basically, it bounces off a wall. Yeah. And let me guess, is the question what's the impulse or something?
Firstly, state the relationship between force and momentum of an object.
Okay, so that's Newton's second law written like that. Okay. Secondly,
B1 is determine the magnitude of the change in momentum of.
right, so B1 they want delta P, which will be mv minus mu, which will be mv minus u, which will be 0.3, 12, no, sorry, minus 12 minus 12. Can someone bash that in on the calculator, please? Got an answer? Kim, what you get? Say again? 7.2 kilogram meters per second. Okay, what's the next part, Andek?
If the collision takes 0.15 seconds, determine the average force acting on the ball during the collision.
Okay, so that's delta P over delta T, which is 7.2 over, what did you say,
0.15 seconds.
0.15 seconds. So what's that, Kim, please? Yeah. Do you know what? Let's see how you did on that one. We won't check Siva because she's not here. Who's this?
Is it negative?
I won't be for this one. It's not such a major deal, but you're right. Probably should put the minus in. Yeah. So Andek, it was just a formula. You didn't. I don't think you needed to put in words. But what you said is right.
But I will get it marked.
Well, you might. Oh, Andek, you didn't change your 300 grams into kilograms. You kept it as 300. So, tut for you. Where's my pencil? Where's my pencil? I have exactly one pencil. I don't want to lose it. Oh, anybody got a spare pen? Oh no, I found it. Right. I shall do a sad face instead of an X. Gow's not here, or Chow's not here. Matt, how did you do? Happy face for you, Matt. Kim. at least you remembered to change it to 0.3, but you only had the 12 once. You only had one of the 12s here, not two of them. Okay, so you'll get a sad face. There now. Alright, next one. Is that the end of number 1, yeah? Okay. 2 sads and 1 happy. Alright. Okay, Kim, you give us number 2 now.
The 3D disk is rotating at 20,000 revolutions per minute and has a radius of 6 centimeters.
Cool.
Show that the angular velocity of the disk is approximately 2,000
Okay.
rad.
Rads, yeah. Per second, yeah. So omega is 2 pi over t, but t is 1 over f, so that's 2 pi f. The only problem is this guy is in minutes, and we need it in seconds. So that would be 2 pi 20,000 over 60. And does that equal, that must equal roughly 2,000, because they said it should be 2,000, isn't it? Looks okay, Kim, for that part? What did you do, Matt? Oh yeah, that is okay. Is it? Oh, you changed your 20,000 over 60 into 1,000 over 3. Yeah, you simplified it, yeah, that's fine. And what are you dividing by? You divided by 6, not 60. Okay. Right, let's continue. So what was part B? I see some of you have the answer here. Was the question in what's the direction of the force? Yeah, so the answer is to the center, yeah. What is it, Andak?
In the center.
Correct. So why did you leave that blank in your exam? If you know it. Alright, and what's C?
Determine the magnitude of the centripetal
Mm-hmm.
acceleration of the point of the edge of the disk.
Alright, so that's A equals, one formula you could use is omega squared or if you want, you can say A equals V squared over or, but the problem is you don't know V. So V is omega or. So that's omega squared or over or. So if you want, you can just jump to saying omega squared or. It's fine. And omega is... omega you worked out. It's about 2,000, roughly. Whatever it is exactly. Oh, so it's 2,000 squared times 0.06. Hopefully that is fine. What's that? Well, was it exactly 2,000 or...
2094.
Oh, okay, 2094, right. Better use 2094. What you get? Pretty big number, yeah? What you get?
263,094.
263. So that's 263,000. What's the unit? Meters per second. Not. No, just meters per second squared, yeah. Not marked. Radians per second squared. Which is it, meters or radians? No, make a choice. Pick one. Meters per second squared or radians per second squared. Go on, you have to pick one. And you will pick Oh, Matt, it was meters all along, and you wrote radians in the exam here. So, what that would mean is you would lose 1 mark there in that question, the wrong units. Now, the reason is just because it's simply A. It's just A. That's all it is. But I'm confused, Matt, because your answer here and here are different. Can you double check 2094 squared divided by 0.06?
Divide times.
Divide. Oh! Flippity flip flip. I made a mistake. I made the same mistake you made in the exam. The A... Hang on, something's gone wrong here. The heck? What's the formula? I've gone confused. Is it V squared over R?
Yes.
Well, oh! Yeah, sorry. You're right, this is omega squared or. Yeah. Yes. Oh yeah, sorry. In my brain, I saw this letter as omega, so I was getting very confused. I was saying, how could omega squared or and omega squared or be the same? That's why I was getting confused. Sorry. So it's v squared over or omega squared or. Now, which one do you have to use here? You have to use omega squared or, because you know the omega. Sorry. So it should be 2094 squared times 0.06. What's that?
263090.
Yeah, so it is that answer then. So I think what you did wrong here, Matt, is you used this formula, but you put omega in for V. I think this is your mistake. So I will give you a half happy, half sad face. Kind of an angry face, maybe. Kim, you get a happy face. And sad face, and you actually knew some of the answers there, but you didn't say it in the exam, which I don't know why. Okay, Matt, number 3 looks like, what was it, thermodynamics?
Which is the greater temperature?
Oh yeah.
293 K or 15 Celsius.
So you have to convert 15 Celsius into Kelvin. So if you add 273 and 15, 288. So obviously the first one is greater, which is fine. I think you all got that. Yep, good. Okay, what's the next part?
Water in a metal pan is heated up to its boiling point. Why was there a net transfer of thermal energy from the pan to the water during the process?
Why was there?
Net transfer.
Yeah. So the question is, why was more heat transferred from the metal to the water? Is it? Why was there a net transfer? Is that what they're asking? Yeah. So that's kind of a weird thing to ask, but the reason is the water must gain heat energy from its surroundings in order to rise in temperature. Now, I don't know how many of you got anything like that. Let's have a look. What did you say here, Kim? Because the pan was hotter than the water, which means that the pan had more thermal energy than the water. True, I think that's okay. Water has a heat capacity No, Matt, sorry. Nice try, though. Because the heated particles escape the pan due to its energy from the heat and moves towards the water and heats up the water. Yeah, okay, that's fine, Andek. So, there's one part left, C here. Okay, go ahead,
What is
Matt.
the
Huh?
What is the next?
The net transfer? It means like the total transfer. So, what's happening in real life is some of the heat goes from the pan to the water and some of the heat might go from the water to the pan. But in total, there's more going from the pan to the water than the water to the pan. You asked me what do they mean by the word net. Yeah, it just means total. Yeah. Okay, what's the next part then?
100 grams of water at 100 Celsius is converted to steam at 100 Celsius. Determine the energy gained by the water during the process.
Okay, so it's 100 grams of water at 100 Celsius, did you say? Becomes 100 grams of steam?
Is converted to steam at 100 Celsius.
Alright, so what formula do we need there? ml just, yeah. And the m is 0.1? And I'm sure they give you the L. What's the L in the question?
2.3. Yeah,
What is it?
2.3 times 10 to the power 3.
Now just be careful. You're saying 10 to the 3 because there's a kilo or because they say it?
Grams, joules, per grams.
Good. But did they give the 10 to the power of the 3?
Yeah.
Yeah. And there's no kilo anywhere in their units, is there? No. Okay, so we're good. Alright, so the answer is 2.3 times 10 squared, which is 230. Oh? Is that right? 230?
This is 2.3.
2.3 times 10 to the power of 3 joules per gram.
Per gram? Oh, those sneaky guys. Those sneaky guys. So I should have kept this into 100 grams. Sneaky. So, what's that going to be? No, that's 2, 3, 1, 2, 3, 4
Joules.
joules. Yeah. Who got that? You made the mistake I did, Kim, with the units. So you made the same mistake as me. Matt, you also made the same mistake as the two of us. And congratulations, Andek, you didn't make that mistake. You got it right then. So, yes, actually, Andek, you got question 3 fully right. So you got a smiley face for that. Matt, sad face for you. And Kim, you know, it's I give you a little smiley face. There we go. Okay, right. Back to you, Andek, number 4.
Define potential difference between 2 points in a circuit.
Oh, goodness sake, what is it? It's a potential difference of 1 volt means that 1 coulomb of charge can be doing 1 joule of work. What was it? Something like this. We have it in our notes, don't we? So I think we want to have something. To get the definition marks, I need to see something about 1 coulomb and 1 joule of work. Are you going to give us the precise definition, Matt? Go for it. You have it in your notes? It'll be near the start of the chapter, I'd say. Oh, that looks like fields. It'll go way back to semester 1. There we go. A little bit more. Oh yeah, maybe a roundabout coming up now. That could be it. No, sorry, you're right, a little bit more. Yeah, before that triangle. Before the triangle. No? Oh, you have it?
Electric potential energy per unit charge. 1 joules of energy per 1 coulomb of charge.
Yeah, good. Yeah, so I want to see basically, your definition needs to have 1 joule per 1 coulomb is the kind of key thing here. Did any of you have that? Kim? No. Actually, you decided to give up on number 4. So... nope. No, okay, none of you got that definition. Okay, I'm going to have to check your notes. Right, what's next now? Part B.
For a particular application, the cell is chosen with the following characteristics: EMF 1.6 volts, internal resistance 1 ohm. The cell is connected to a resistor of 10 ohms.
To 10 ohms. Okay. What did they ask? Or what's next?
Determine the current which will flow through the resistor.
Fine, okay. What will we use? We could just use VIR, couldn't we? VIR? So the I equals the V over the R, which is 1.6 over 11. Yeah? What you get there?
There's internal resistance.
Oh yeah, that's 1, isn't it? I added that to the 10. Yeah? What do you get here for this? Ah, well done, Matt. You used Kirchhoff even though you didn't have to. And I think you got the same answer though. 1.6 over 11. What's that? Is that 0.145? Yeah. So you got that, Matt. You divided by the wrong resistance, and you divided by 1. You didn't include the 10. So you just forgot the 10, okay? It's 11 in total. Right, what's next, Andek?
Determine the terminal voltage of the cell.
Determine the voltage. Oh! V equals IR, which is 0.145 times 10, which is 14.5 volts. Now look, they want the voltage here.
Isn't it 1.45?
Oh yeah, thank you. 1.45. They want the voltage here, which is the same as the voltage here. So it's 1.45. Good. Yeah, okay. So, sad, happy, sad. Okay. Right. Kim, number 5.
On the surface of one of the moons of Jupiter, the field strength is 1.4 newtons per kilogram,
Mm-hmm.
and the moon has a mass of 1.5 times 10 to the power 23 kilograms.
Mm-hmm. Good.
Determine the radius of the moon.
Good. So that's using this formula. So you get R is root GM over G. So that's root 6.67 times 10 to the minus 11 times 1.5 times 10 to the 23 over 1.4. So if you bash that in, please, let's see what we get. Give me 3 significant figures. 2, 6, 7. How many zeros? 4 or 5? Which? 4. It looks like here. What's after? Is it 2, 6, 7, 4, 0, 5, 0?
2, 6, 7, 3, 2, 8, 0.
Yeah, 4 zeros. Yeah. Yeah. So let's have a look, see. What were you thinking, Ken? What were you thinking? You were mixing two formulas. Yes. Yeah. So Kim, just to be clear, to give you a little bit of feedback. So you use this formula, which is fine. You could do that. But then I think you mixed it with like this formula or something. Something like this. But you can't, because this one is for electric fields and this one's for gravity. What you needed to do is you could use that formula together with this formula. You could mix those two if you wanted. So you would get MA equals GMM over R squared. You could cancel the M's. You could bring R squared up and bring the A down. And you'd get root GM over A. And the A is the same as G, which in this question is 1.5. So you would need to use those two for the way you tried it. Okay? And I see you didn't have any luck with this one, Andek. You're totally confused. Yeah. Okay. Let me see. Matt, how did you get on with the first part? Okay, that looks okay. Right, so what's the B part here then?
State the acceleration of an object at the surface with the moon.
Oh, I said 1.5. It's 1.4, sorry, Kim, 1.4. And the answer is 1.4. It's the same. The A and the G are the same. So, good. What did you say? Poor Kim, you tried to calculate it. So sad. Well, okay, Matt, I think you're next. Is it 6? What we got?
A stationary wave pattern integrated on a string which is fixed at each end. A. Sketch a label program to show a stationary wave pattern on a string with 2 antinodes.
2 antinodes. Okay. There we go. It has 2 antinodes. One here and one here. Oh no, it doesn't, dirty liar. It had, sorry, I drew 3 antinodes. There's one in the middle. Let me try again. I want 2 antinodes. Oh, just this. There we go. So there's one antinode, there's another antinode. So they're antinodes. And by the way, that guy there, that's a node. What else are they asking to draw in it, or what else is happening?
Then B.
Yeah.
If the length of the string is 35 centimeters, determine the longest wavelength which can produce a stationary wave on a string.
Grand. So the longest wavelength is when you can have this. Because this would make a wavelength of 70 centimeters. So 70 is the answer. Yeah. How did you guys do? Kim, your picture is okay, but I don't know. You kind of continue your graph on a little bit here. And I really, really shouldn't do that. But it's okay for practice. But it doesn't look like you got... Did you say 17.5? You divided instead of multiplied, perhaps. Matt? Oh, Matt, you had no idea what to do here, huh? And you tried to draw something, but...
It's
not it. I'll give you a half smiley face, Kim. Alright. Is there more to 6? No. 7 now. Oh. 7 now. Okay, right. Back to you, Andek. Is it 7?
When considering the photoelectric effect, zinc has a function of 4.3 electron volts.
Okay, 4.3 electron volts.
And determine the threshold frequency for zinc.
So you have the formula, what is it? HF equals work function plus KE, right? And the threshold frequency is when there's no KE. So the answer is work function over H, which is 4.3 E over H. Whatever that is. Maybe one of you could type that in to check.
1.04 times 10 to the power 15.
Thank you.
15. Yeah,
15, there we go. Okay, what's the next part now?
Explain what happens when monochromatic light of frequency 1.5 times 10 to 15 hertz is incident on the surface of zinc.
1.5 times 10 to the 15, yeah? Right, folks, what happens here? So you have this frequency of light hits the zinc. What will happen next? Zinc. What will happen next? Electrons are released. Why didn't you say that in your exam? You knew it.
I watched your video.
Ah! Okay. You didn't know it at the time. Okay. Good man. So, I'll give you half smiley face. Kim, how'd you do on this one? You got the formula, but you didn't calculate the F. So I don't know what to make of that.
That's it.
Hmm?
It's 3 months.
What's 3 marks? For the second part? Oh, okay, read it again. What did it say? Maybe I didn't hear something. And could you read that question again?
Explain what happens when monochromatic light of frequency 1.5 times 10 to 15 hertz is incident on the surface of zinc.
Okay, so because it's 3 marks, we better give them a proper sentence. So, blah, blah, blah. Since the frequency is more than the threshold, enough energy will be transferred into the electron, thus freeing it and giving it kinetic energy. There now, I should keep them happy. Yeah. Oh, what happened to you, Chow?
I forgot.
You forgot about me?
No, I think it's start at 2 p.m.
Oh no, it starts at 1 p.m. today. Right, now that you made it, I can check your exam. Let's see.
Do we need a laptop today?
In the second class. Oh, well done. You got some right. Some right, some half right. Not too bad. Not too bad. Yeah. Okay. Right. There's a B part here, is there? No.
No, that's the B part.
That is the B part. Okay. So what are we on to now? What question now? 8, is it? Yeah. Right. Kim, is it? Give us 8. What time are we at? How big is 8?
2 questions.
How many marks?
4.
Okay, we'll do 8, we'll take a break, then we'll take out the laptop and look at the coursework then, okay? So, right, go ahead, Kim.
Define electric field strength.
Anyone want to try electric field strength? Let's see. You tried your best, Chow.
What?
I'm looking at your answer. Yeah, you did a good try, but not fully right. Let's see what you wrote, Matt or Andek. Now, close, Andek, I think. Do you know, I think I probably would give it to you. You said electric field strength is the value of force over the value of charge. I would have preferred if you said the value of force per charge.
What if I just put the equation instead of the words?
No. What you have is kind of fine. It's okay. Let's see, who's this? So this one is you, Matt, isn't it? Electric field strength is the force over charge. Ugh, okay, but nobody wants to use the word per. The straight dead. Yeah. No, Kim. Sorry. Not quite. Not quite. You three are okay, but I really wish you would just use the word per. Where's my pen gone? Please try to use per rather than over. Okay, that's fine. Right, what's the next part?
In our vacuum, 2 points of charge, 1 of 2.5 millis.
1 point.
2.5
Yeah.
millicoulomb.
Yeah.
The other of minus 3.5 millicoulombs.
Let me guess. What's the force? Is that yeah? Is that what they're asking? What's the force?
I separated by 50 millimeters.
Oh, thank you. I need to know the distance too. Yeah, separated by 50 millimeters. Yeah. So, firstly, which direction is the force? Attraction or repulsion? Which direction, guys? The force going this way or it's going that way?
This way.
Yeah. Why?
Positive
Positive
and negative.
and negative. It's the attraction force. Okay. So the formula is, you know this one, 1 over 4 pi epsilon 0, Q1, Q2, over 50 times 10 to the minus 3 squared, and that is towards each other. Sorry, attraction. Attractive. So if you put that in a calculator, what do we get? What the heck, guys? None of you did that. Why the heck not? You all know this formula, don't you? Guys, you all know this formula, don't you? Yeah, none of you did it. You all get sad faces, I think. You're all getting sad faces because I'm not happy that you didn't try that part. What is the answer here? No? Did you have this part in, Kim? Okay. So you calculate this part. Fine, no, that's fine.
3, 1, 4, 5, 6, 4.
3, 1,
4.
Yeah.
5, 6, 4. 3, 1.
no. Could no? I mean, it could be. It's really big though. I forget what's epsilon 0. It's quite small, isn't it? Yeah, no, sorry, Matt. You're probably no. I'm sorry. I think that might be right.
But the answer is different.
Why? What does it gives the answer?
Mark's count.
What to say the answer is?
1.38 times 10 to the minus 8.
Oh, let me check. Excuse me. Thank you. I'll check it myself. What did they say the answer is?
Force.
Yeah.
1.38 times 10 to the minus 8.
Can I see the exam for a sec? I just typed in what Matt did and I got the same.
Maybe divide into E.
Say again?
Divide into E. Electron force.
Well, let me see their marking scheme. Oh, I'm sorry. I asked you, is the question what's the force? I should have let you finish the question. The question isn't what's the force, it's determine the force on an electron in the middle. So I misunderstood the question. An electron is positioned. Yeah. Thank you, Ken. That's what I get for interrupting my students, thinking I know what the question's going to be when I don't. So, the question was, here you have one charge of 2.5 millicoulombs, and here you have one charge of minus 3.5 millicoulombs, okay? And then they say, determine the magnitude and direction of the force on an electron that's in the middle. So right bang in the middle here, there's an electron. And they want to know what's the force on it. Well, firstly, let's do the easy part. What's the direction? So which way will the force be? Now remember, this guy is positive, this one is negative, and this one is negative. So what way will the direction be? Left or right? Are you sure? Guys, why does it look like your brain stopped working? The electron is negative, agreed? This guy is positive. Thank you, Kim. Left. Isn't it? Isn't it? Right, Matt and Deck? Yeah, okay. So then the next part we'll calculate is the force. So that would be the force left minus the force right. Okay? So that would be 1 over 4 pi epsilon 0, 2.5 times 10 to the minus 3 times E over 25 millimeters. because it's in the middle. Minus 1 over 4 epsilon 0, 3.5 times 10 to the minus 3 times e over 25 times 10 to the minus 3 squared. I'll type that in.
All these for 2 marks.
Is it only 2 marks for this part?
Yeah.
And they made us write the other thing for 3 marks. That's terrible.
It says it's 3 marks too.
Oh, the exam says how many marks? 3. It says 3 then.
It's like,
Oh yeah, it says 2, but the marking scheme says 3. Okay, so they must have mistyped that. Oh, sorry, let me type this in. Oh, bad teacher. I wrote left minus right, but that's wrong. It's left plus right. Because this one here is being pulled by that, but it's also being pushed by that. So it's a plus here. So I got a very small answer. What's the answer in the marking scheme? 1.38 times 10 to the minus 8? Yeah? Okay, so it's a small answer. Now, Kim, since you have it open, where did they give you the 3? Could you, like, so... Did they give you 1 mark for this? Like, how did they give you the marks? Okay. I know you don't like to talk to me, that's okay. So, you get 1 mark for this, 1 mark for this, and 1 mark for your calculations. Yeah. Yeah.
If my answer is 1.38 times...
That's fine, yeah, that's fine, yeah. Yep. Right, let's see how you all did with that one. Oh, it looks like you decided not to do it. Oh, that's right. Yeah, you didn't do it. That's right. Okay, I was angry that you didn't do it, but I'm less angry now that I see it's a little bit harder. But still, it would have been nice if you tried it. Okay. Will we have a look at Siva's? See how she did. Oh, she made the grand mistake.
can I bring my laptop?
Yeah, you go get it now. Siva was quite sick during the test, wasn't she? And she's out sick today. I can see that. I'll have to talk to her when she's back in. Or maybe she'll watch this video later. She will? She won't. We can say anything we want about her. Well, let me tell you what I really think of Siva.